Ladies and gentlemen, I present to you the SYN Shop podcast. I am, of course, the Mighty Pong.
And I'm Crux.
And you are listening to the SYN Shop podcast. On tonight's show, we've got an interesting one. We've got a guy on, William Hoff of OutOfTheBoxConstruction.com, and he's going to go over with us some of the methods, the madness, and the muck of 3D printing a building. It's going to be awesome. And you're going to love it. But first, we're currently close to the public, but we would like to remind you that while we are close to the public, if you're in a shared space elsewhere, make sure that you wear your mask and clean tools, surfaces, and material before and after you use them. Stay home, don't touch your face, and for Pete's sake, wash your damn hands. Now, to stay updated on the shop's open status, you can check out synshop.org COVID status /COVID status to find out the latest information. To make sure you're notified of future events, including virtual ones just like this, you can join us at meetup.com /SynShop. And of course, for more information about the shop, you can just go on over to synshop.org. And with that, let me introduce our guest. Boom. So our guest here is William Hoff from Out of the Box Construction. They specialize in flat pack buildings as well as the 3D printing of structures out of cement. It's just a high-level view. We're definitely going to go more into detail here in a second. But first of all, how you doing tonight?
Good. How you guys doing?
Oh, living the dream.
Oh, wonderful.
Absolutely.
So, you guys want to talk about doing some 3D concrete printing?
Well, as a matter of fact, we wanted to learn just a little bit more about you first. I wanted to ask, first of all, how long have you been involved in construction in general?
I've been 43 years in construction, both as an iron worker, crane operator, carpenter, 13 casinos, worked as a superintendent, retired around 60, and then became a general contractor licensed here in Nevada.
Oh, that's awesome. So when did you start getting more into like the sustainable building technology?
Well, it was during my retirement. I built casinos my entire life. I thought I'd get into something a little bit more value, something that we can actually bring new technologies in to develop low-cost, sustainable housing.
Oh, that's great. So how long ago did you start Out of the Box? Was that about
Out of the Box, actually, it was started about 5 years ago. I've been a contractor for 4 years, and I've been working through different sustainable systems, precast concrete, different specialty concretes. I first used Portland, then got into geopolymer that we'll talk about later. And just kept on that path trying to find out new technologies that we can use, and some of it's old technologies. What we can actually put together to make what sustainable houses are.
So a lot of times people will throw that term around so much, sustainable, that I feel like sometimes that it loses
Context.
Context. Yeah, that's a good way to put that. Yeah. When you say sustainable technologies, how do you mean?
Okay, sustainability means something that's going to last and be able to be utilized in a positive method, which is positive to the planet. Eco. We in all the constructions we do, we target for net zero, solar voltaics and solar thermal. So we can use the sun for temperature control. So we do that, and then building materials, sustainable materials that can actually, we're starting to work with recycled materials, being able to use garbage to build concrete. And then finally, we look at things that we can integrate into the house, like aquaponics, so your house can actually grow food for you. So it's my company's focus is sustainability in things that are able to be integrated into a dwelling that creates not only an eco-positive method, but independence for the family, or the independence for the people. So it lowers your your energy cost. It helps create food. It creates security because our materials are fireproof. Down to reutilizing the 80% of the house's water and so forth.
Okay. So it sounds to me like when you say sustainable, what you're saying is that the systems in the house aid towards keeping the house running rather than, how do I put this? Rather than being something that you have to continuously pump, let's say X number of energy into, you're pumping significantly less into it. Is that kind of where you're going?
Basically, it's money. You have to pay for water, you have to pay for electric, you have to pay for food. And what we're doing is we're trying to create houses that help give you independence. It helps lower the cost of energy, reutilizes water, grows your own food so that you don't have that third-party necessity, I would say. You're independent, and you're also green. You're working within technology to help introduce new technologies that are sustainable.
So I'm turning to the you mentioned about the polymers earlier. So the part that everyone gravitates to at first, when they hear about 3D printing buildings is usually the machine, right? They're like, oh, I can't wait to see the big machine and blah blah blah. But really, is the secret as far as I understand is actually in the mix, right? In what you put into.
Exactly. There's a lot of different printers out there, be it robotic arm or be it gantry style. Actually, the printer that we developed, we put out open source for basic low cost printing. The issue that we have is actually the material, the concrete that's used. Basically, nowadays we use Portland concrete. But what we're looking to do is change that because Portland concrete's very dirty. One ton of Portland is 1 ton of CO2. It's responsible for 12 to 15% of the air's pollution. So we're gravitating over to what you're showing geopolymer concrete, which is 88% more sustainable. It's also fireproof, waterproof, and acid resistant because it has a different chemistry. We don't use water to create geopolymer. And a lot of people, when you say geopolymer, they instantly think of plastic. The term polymer.
If you got the audio of the video you're showing.
That's right.
This is actually Red in Russia. They worked with the university to develop these different inks.
Give me just 1 second. I'll get that turned off of there. Get out of here. That should be significantly better.
Okay. So trying to switch to geopolymer, and you can actually think of it as old Roman cement because it comes through more of the idea or philosophy of a different chemistry.
Okay.
As I mentioned, the Portland's very dirty.
Okay.
What we're trying to do is go with a cleaner concrete, which is superior. That concrete you're looking at, we value it in compression strength. That's 10,000 psi concrete. But the nice part about it with geopolymer, it's what we call a structural mortar.
Okay.
When you put one layer on top of another layer, it fuses together. Where Portland would normally have a cold joint, it would snap apart. You can come back weeks later and put another layer on top of this, and it fuses to itself. So the chemistry is completely different, but since we're using waste product, we're 88% more sustainable. And it's a superior product because Portland's not fireproof. It explodes from the trapped moisture inside. This doesn't. This has no water in it, which also helps cleanup. We use a little bit of water for cleanup, but we recycle it, we filter it, and use it again.
That's interesting that you bring that up. Well, that's way too loud. That's interesting that you bring that up because whenever at the shop we sometimes do metal casting, and that's one of the things that we have to warn people that are starting to take it up against is do not drop molten metal on concrete because it'll pop. And so that's interesting that you brought that up, because that is definitely a concern. Even in fires, I'm surprised it will explode at those low relatively of temperatures.
Yeah. Also, Portland concrete isn't waterproof. It absorbs water, and it actually doesn't really ever cure.
Right.
And Portland will last for roughly around 80 to 120 years if it's really good Portland. Otherwise, it starts deteriorating. Geopolymer lasts for 10,000 years. And some of the other types of geopolymer, some of the early types, like Roman concrete, is used in the limestone aqueducts in Rome, or the Great Wall of China, still standing.
One of the first questions that I got about this, whenever I talk about the 3D printing a building, is how do you keep each layer from crushing the ones below? That sounds to me like you kind of went over that with the stuff earlier about it's all about the geopolymer, and that's what keeps.
Well, you can look at some of the other companies. You can Google 3D concrete printing. You have Icon in Texas.
Okay.
They use the Vulcancrete, which is, I suspect, a monocalcium aluminate, which is behind the Portland line. Or a lot of guys are just using concrete mortar like you use between bricks. The key to it is to be able to have the viscosity come out at the rate you need to, so it dries fast enough to support the next layers. Geopolymer can dry very quickly. That's why some use the monocalcium aluminate, is because it dries very quickly and it's very strong.
Okay.
Yeah, but it's all viscosity.
So we had talked earlier, and Jim, let me know if I have not fixed the audio issues that you were telling me about. They should be fixed, but let me know if they're not. But yeah, so on the phone earlier, what was that? Earlier this week, I think it was. We talked a little bit about Earth ships. Now, you came from, you grew up for a while in Taos, New Mexico. Is that?
Actually, I was in Rio Doso, New Mexico. My family lived there for a long time. Back in those days, I'm 60, so that was 40-something years ago.
Okay.
And it was kind of it was a different era. It was more what we would classify as a hippie era.
Okay. Where
we all transported through the Four Corners, and we did a lot of Indian, and a lot of us got into the compressive earth type housing using tires. My brother and I, we built one out of straw bale covered in concrete. And yeah, I've been doing this a long time. Not necessarily with the guys in Taos, but further south.
Yeah. So you had mentioned on the phone that one of the issues with that, because that's one of the things I had been interested in a long time ago, was earth ships and what are they called, shipping container homes, stuff like that. But we had talked a little bit about that, and with rammed earth and tire construction, there's a lot of concern with moisture and bugs and fire and that kind of thing.
Yeah, you have the earth is a great insulator.
Right.
6 feet down, you're at a constant 65 degrees. So it's the same reason we used to have root cellars.
Yep.
It's because it preserves things well because of the cool. And why we build our dwellings on top of the earth, I'm not quite sure. However, if you do go underneath, you can collect that cool and actually project it upstairs through embedded water lines in the floors for radiant heat or radiant cooling. With all that, we're trying to use technology to improve the quality of the structure. We're looking at different concrete methods that can not only insulate, but to protect you from fire and flood. The nice thing about geopolymer is if you do get flooded, you just dry it out, and it has absolutely no effect on the concrete whatsoever. But then,
so then, does that make it watertight? Wouldn't there be concerns?
Yes.
Would there be concerns with mold? Would be my question, or do you need to have just ventilation installed and it's fine?
Well, with all dwellings, you have ventilation. And one of the reasons that I became a licensed contractor was to learn the International Building Code, the IBC and the IRC, the International Residential Code. And that was the whole education that I went through to get that license, because all my years of construction, I really didn't ever learn the business portion of how to go in and pull permits and make the government happy, so to speak.
Mm-hmm. How to give the inspector what
a lot
want.
Of people have. Yeah. I won't even touch that.
That's fine. Yeah, but yeah, a lot of times we had a couple of inspectors that we would just basically like, what do you need to see here? Well, I need to see a fire extinguisher on every floor. Okay, here you go. Boom.
I've gone to a lot of inspectors through my entire career that you kind of wonder where they got their education. But even with that, a lot of people have a lot of great ideas about construction.
Yeah.
Not very many people actually understand how to meet the code. Where does the rubber meet the road? Because you can't make a house out of cardboard, but you need to be able to have enough code compliance and still keep the costs down. That's where I specialize. That's why I got into 3D concrete printing, because it's very low cost construction. Mm-hmm. They call it additional construction. And what we would call the ASTM, the American Standards and Measurements, have not been written for 3D printing.
Oh, okay.
So for you to be able to run down and pull a permit is not something that's going to happen tomorrow.
Right.
However, the ASTM is in October in Florida for printing houses.
What is in October? Oh, they're going to be reviewing the codes in October?
ASTM, the standard. They're working on. They actually asked me to submit papers, and they are reviewing all the documents from all over the world for how they're going to write those standards for building code for printing. That's why we're trying to get into the geopolymer ink, because it's a much more superior structural mortar.
Ah, okay, gotcha. Interesting. Okay. So
the code.
I wonder.
The code is daunting.
Go ahead.
The code is daunting. What most people don't understand is the International Building Code does not come from the federal government. It comes from the United Nations.
Oh, is that right?
So what? Yes. What we use here in the United States is the same thing they use in South America or Europe.
Oh, wow.
It's an international building.
Huh.
So
I actually talked to there's a guy that I do a gaming stream throughout the week, and there's a guy that was joined on one of my channels. He was from where was he at? He was over. I know he was in Europe somewhere. I can't remember exactly where. He might be on the show. He might be in the chat with us tonight. But at any rate, he is a mechanical engineer over there, and he mentioned that one of the big differences between stateside and Europe is that Europe uses concrete significantly more than we do here in the United States. I guess we use a lot more wood and brick, whereas they use a lot of poured concrete. Has that been your experience as well, or?
Oh, absolutely. Not only Europe, but South America, Asia. Most tropical countries use concrete because of the termites. Will decimate your structure. Mm-hmm. That's why Mexico, Central America, South America is mainly all concrete.
Oh, okay.
We're the only country that really uses cardboard and 2x4s and all the other stuff.
Cardboard and 2x4s. So one of the things that I thought was really interesting with when we talked earlier this week too is your mix is actually open source, right?
The mix isn't open source. The mix is our printer is open source.
Okay.
We have put all the links of all the components that we have on it on our website for people to be able to download and build. So it's costs about $28,000 if you build it yourself. But we also make them and sell them at about $46,000.
Makes sense.
The next market is about 170,000 for a comparable printer, because a lot of people are just trying to sell them to make money.
Yeah.
We're trying to get technology into people's hands to be able to kind of change the curve.
That makes sense.
Get this out.
Yeah. So I guess really, speaking of the machine, yeah, we'll go into that. Sure. That is kind of the part that people are probably the most curious about. So what, I guess a good way to put this would be like, how do you see that as being different from a 3D printer, or is it at all?
It's really not. It's a gantry printer. And as you do research, you'll find a lot of different types of printers.
I should have the volume down now. I'm not sure. If I don't, let me know.
Not sure.
You can go ahead.
Yeah, I'm hearing background music.
Yeah. Just, how about now? It should be off.
That's better.
Hey, yeah. Okay, good deal.
Yeah. And there's a lot of information from a lot of different companies. Yeah. Europe is way ahead. We have not even scratched the surface. Icon in Texas, I would say, is probably the leader in the United States. They got $5 million startup money from D.R. Horton. So their technology is not really available unless you buy it outright.
Okay.
They're not looking to do a lot of open source, I guess you would say, like we are. The ink itself comes from the Geopolymer Institute in France. It's by Professor Davidovitz. Has educated several of us, and there are several of my classmates, some of his students, that have gotten together to be able to bring this forward. Renka is our classmates from Russia, and they also partnered with some classmates from Italy, and then I was there both in 2015 and 2019 at class to kind of join with them and now bring it to the United States.
So in the pictures that I've seen, and I might be able to, this is going to be, we're risking it here. Okay, there we go.
Yeah.
What's that?
I said, yeah, it showed up. So.
Okay, excellent. So the picture that we're seeing here, that's how, I'm guessing from the size of that cart in the background, we're looking at something that's about 20 feet wide, 30 feet wide?
It's 20 feet wide and 11 feet tall, and it's on tracks, so it can go continual.
Okay.
5 feet to 500 feet, as far as you want to put tracks down.
So if someone wants a room that's slightly larger than that, how does that work?
Well, we're still working on some larger printers, and we're also going to be working on a robotic arm printer.
Yeah. Go ahead.
We have a small printer that we actually use for testing different mortars.
Yeah.
But this was our standard printer that we came out with, and that we put the components open source for people to join. And we're also going to be doing classes. This printer is going to be going to some property out in Amagosa, where we will start printing the first house, probably as it cools off here. We'll start looking at that and have people come out and be able to just share in technology and to learn for themselves and to hope, I guess, just moving here.
Very cool. So I did want to ask also, so this was, since this is kind of open source, how, I guess what I'm looking for is like how much special sauce is there in the one that you use? In other words, do you take the open source one and like, okay, well, here's what we'll do to upgrade it for our people, for our customers, or is it, or is the printer you're using the same as all of them?
If you go through them, they're all pretty well basically the same. This one that we have here is a more industrial for commercial use, because we were going to use a very large hose. So we went 110 and 220, which is more power than most people need. And we also will explain to a lot of folks out there that really want just a basic easy printer to use a 12 and 24 volt with a gear reduction on the motors.
Well,
which saves a lot.
Wow, 12 and 20. That's all it takes to move the weight of the concrete bucket and all that?
It's a hose. You're just moving the end of a hose like a pin or a...
Okay.
Yeah, so it's
feeder kind of
giant stepper motors essentially. So
yeah,
like the shop out we have at the shop, but bigger.
Yeah. Yeah, that's got to be some torque. Oh, in the chat, let's see, Malachi, I believe your partner, he says that the dimensions William stated are internal. Overall width is 22 feet. So, and
to the outside.
To the outside, yeah, yeah. But we were looking for internal on that, so that's either way, good to know.
We want most people want printing area. How big can I print my house?
Exactly. Yep. So that's interesting. So, I mean, one possible thing that you could do is, Malachi also says NEMA 34 steppers use 4 amps each. There's 6 of them total. Okay.
All right. Yeah, that's nice.
Yeah. So, I'm sorry, I keep cutting you off. Did you have anything, Crux?
No, I guess that might be my partner, John. He did all the robotics and the electronics on it. I did more of the frame, bolting, grinding, that kind of structural. I would have never been able to get this completed without him. So I want a thumbs up to John.
There you go.
Awesome. Yeah, he says the printer in the picture uses NEMA 42s, which runs off 220 volt and are 8 amps.
There you go.
Awesome.
And it's a great little machine. We'll be bringing out some pictures of the printing that we're going to be doing. It's just, we all have day jobs, we all work, and it's not something that we get to do full time.
Yeah.
Maybe in the future, once we start printing, making more printers for folks, but right now, this is just the beginning.
Awesome. That's really cool. So just to recap real quick here, we are again. Sorry, I've completely lost my place. There we go. We are talking again from William Hoff from Out of the Box Construction, and we're just basically talking about methods of 3D printing an entire building and the various things that his company does in order to make that happen. Speaking of making things happen, if you would like to see us make some things happen, you can tune in on Monday nights. Was that a segue or what? You can tune in on Monday nights to watch our project night. That's at 7:30 right here on Twitch. And let's see. Last week we got the 909 drum module is finally done to be a normal drum module. Now this week I'm gonna kick it up a notch. I'm gonna turn the dial to 11, and we're gonna see if we can make it talk. So that's what we're gonna do. That's my project for Monday. Do you have yours yet, or are you're gonna?
Well, I do have my laptop back, so I can actually do multiple cameras now. So I'll probably work on the 8-bit computer again and get that, move forward on that project. So probably get the clock module assembled on Monday.
Oh, that's going to be awesome. It's going to be awesome. All right, so we're going to be doing all that, and so make sure that you tune in on Monday at 7:30 right here, same place, in order to do that. Also, we're going to be having a post game after this, and in that, were you planning on sticking around for the post game, William, or you're just going until 8:30 and then done?
Sure.
You're sticking around. Okay, fantastic.
No, I'll stick around.
All right, so we'll be talking shop and doing the thing. So stick around for that. That is only on Twitch. You'll see this part on YouTube tomorrow night, but you won't see the post game there. You gotta hit Twitch for that. So
unless you're actually watching it on YouTube right now, and then you'll see it right now.
Well, that's a very good point. All right.
Yeah.
Okay. So in the future, for the people on YouTube, welcome to Saturday. But you're only going to get an hour of it. So, there it is. Also, if you would like to, by the way, I need to point out this snazzy shirt right here. If you yourself would like one of those, you can just type !merch in the chat, and you can see all of the fantastic things that we have available for you. We've got the old school SYN Shop shirt available. We've got a whole bunch of different ones like this, and every single purchase goes directly to helping the shop, and we really, really appreciate it. So, getting back to other stuff here. Oh, there's a video I forgot to play, so I'm going to play it. I'm going to bring it on, and then I'm going to probably have to turn the sound off real quick. Go there, here. Do not hide in the mixer. And turn it the F down. There we go. All right. So we kind of skipped past this when we were talking about the mix, about the geopolymer. There it is. So you had mentioned that it was fireproof. When I saw this test here, I was like, well, he's not playing because that's a lot of heat.
Yeah, this is an interesting development. What this is hemp, coated with geopolymer. And because we're always looking for waste products that we can use to make low-cost construction materials. And we came across this component. We have several others, but this is very interesting because it's very low cost and it's completely fireproof. One of the things that we found with the geopolymer is the chemistry from geopolymer actually chemically petrifies the cellulose, the wood.
Okay.
So it becomes an aggregate. It becomes rock. So when you do that, then it becomes fireproof, as you can see with this cookie. It's kind of like this one here that we work with. And it becomes completely fireproof. So as far as code goes, they usually want a 2-hour burn wall. We can make a 24-hour burn wall, and we can make that with waste products. So This is hemp. You can use cardboard, newspaper, wood chips, and anything made of cellulose.
That's incredible. So yeah, well, I mean, old newspaper right there. Well, I mean, not as many people are reading newspaper now, but that even just newspaper, that does take a lot out of the landfills and so on and so forth. But now, the question that I would have is that so for years when I was growing up, I remember seeing Ed Begley come out with the first electric car, right? And it was ugly. And it was terrible, and it got like all of 40 miles to the charge, which took, like 12 hours to make or something like that. I'm talking long before the Prius and all that stuff. So ever since then, we're about 10 years away from having electric cars. Oh, we're 10 years away. Like pretty much my entire young adult life, we were 10 years away. And then all of a sudden we were here. And I think that part of the reason that is the case is because it actually is at a point now where, what we would call sustainable technologies are actually in some cases cheaper than oil or coal or, so on and so forth. Are you finding that to be the case with these materials? Are you finding it to actually be cheaper, more cost effective for you? Which is good.
Well, now that we've done pretty well getting the geopolymer formulations down. Theoretical chemistry wasn't my favorite subject. However, I've endured to be able to learn this. And what we're doing is we're now trying to head into what I call a super green material, as you're showing here. If we can start using waste product or garbage or recycling material to be able to make construction materials, then we're one step tenfold over on being able to help the environment. We have also mixes that we use rubber tires, ground up rubber tires, polystyrene, plastic bottles. We're looking at everything because of the geopolymer is so structurally compartmentalized that we can use it in many different phases.
Okay. But so I guess really though, I mean, and all that is fantastic. Don't get me wrong. But my question is more along the lines of financially for you as if you put your builder's hat on, you put your GC's hat on, right? You've got stick frame construction and you've got construction using a geopolymer. Which one is it that makes more sense to you from that perspective, financially?
Well, Yeah, financially right now it's everything that we use because the infrastructure is set that way. The drywall is made of gypsum.
Mm-hmm.
However, it's covered with paper, so it's not necessarily fireproof, but it's definitely not waterproof.
Right.
So what we're looking at is trying to change that paradigm and creating the infrastructure so we can start bringing these materials forward.
Mm-hmm.
We have a lot of pushback with the industry leaders now because they make a good portion of money from their products and they're tied into the code
Absolutely.
that they're called for. But if we continue on, then sooner or later we're going to start making strides in the market, not only because of the cost and the quality of the material, but then it's also the environmental considerations that we bring forward where they can.
So it sounds to me like the infrastructure, and see, so this is one thing when we first started with the whole shutdown and quarantine and all that stuff. A lot of people were saying, "Oh, it's the people hoarding the toilet paper. That's why we can't get toilet paper." Blah blah blah. But really, what it was is you had two distinct supply chains, right? That which serviced businesses, right? You know, the Burger King down the street doesn't buy rolls of Charmin. They get giant rolls from Georgia Pacific, and they put that in the big giant thing that never rolls when you try to pull the thing. But anyway, and at the same time, so that part over there, the Georgia Pacific, all of a sudden, no one's showing up to work, so they are just sitting on warehouses full of toilet paper. And meanwhile, Charmin, everyone's staying at home, so everyone needs more toilet paper. So it's like a lot of I'm not saying there was no hoarding, but a lot of that was not actually due to hoarding; it was due to supply chains. And so, what I'm picking up, the reason that that's related to this discussion, just to close the loop here, is it sounds to me like a lot of the supply chains aren't in place yet. I'm certainly not poo-pooing it. We no poo-poo intended whatsoever. But it sounds like the supply chains are currently being constructed to make geopolymer come out ahead from a general contractor point of view.
First of all, the geopolymer is I'd say it's a hard girl to date. It's a very complicated formulation that you really need to take your time to be able to learn it. It's some depth in chemistry. When we say geopolymer, a lot of people think that polymer is plastic.
Right.
I want to make this clear because polymer means a long chain of molecules. And when we say geo, we're saying that we're connecting minerals together in a long chain of molecules. So there's no plastic in it. And as far as the supply chain where it comes to recycled materials, where does the recycled materials go that Republic Services picks up and takes away?
I actually know the answer to this, but go ahead.
They're not going to China anymore, and they're having a lot of issues of where to put this and what to do with it. And then you have us coming up and saying, so what are you going to do with it? We have some answers that we could use. However, I've had a very difficult time trying to communicate with them because they're set in their ways and they don't want to change.
Yeah.
We're persistent and we're going to keep going after them until we can get our hands on their materials and then show them the superiority of the products that we can make with the chemistry that geopolymer brings.
Yeah, I mean, well, especially if they're in a situation right now where they can't get rid of it. But from what I understand, a lot of that stuff that you put into the recycling bin, it ends up going into the landfill anyway, or into the regular trash. A lot of the stuff that...
Exactly.
Because they don't have anywhere to ship it to.
And that's what we want to change.
Right.
We're working very hard to be able to bring a lot of this science forward. I can't give people geopolymer formulas because there's thousands. Basically, every mineral that you can find a way to make it into a rock. Because that's what we're doing. We're making rocks. We call it concrete in our culture. However, we're making rock. And I openly, anybody that wants to learn to do geopolymer, contact the geopolymer institute.org in France, and there's a myriad of information. And if you love chemistry, you found your niche.
And if you speak French, then
oh, it's all in English.
I know, I'm sure.
Everything's presented in English, the videos and everything. And there is a book I'll grab. This is our Bible.
Okay.
If you really want to get into the chemistry portion of it, I would suggest that you get this book out of the Geopolymer Institute and enjoy it, because it's going to be quite an education.
Awesome.
And then you'll be able to understand what we're putting together here.
Very cool. So let's see. I think one of my subjects is going to have to bounce to the post game, unfortunately. But one thing I definitely did want to do in the main show, we got 15 minutes left. But in the main show, though, I definitely did want to talk about basically kind of like your mission, right? When we talked earlier this week, you mentioned about using the technology to bring the cost of housing down, and that is definitely something that could help a lot of people here in Las Vegas. Is that what you were wanting to go to?
Well, one of the things I wanted to mention is to be able to access the information for the printer is on third dimensional printing.
Okay.
And you have Out of the Box Construction is my construction company. But to get to the links to be able to build the printer would be on third dimensional printing. And that's a 3, an RD, and then dimensionalprinting.com. And then it's all on the website, and you can contact us from there, because it's kind of two different separate things we're doing. Because now you're talking about low-cost housing, and then out-of-the-box construction, you're going to start seeing some module housing that we're working on. Mm-hmm. These are basically units that I found in Europe.
Okay.
That I'm bringing here to the United States, because I needed to find out what they do for the refugees in Europe, and they use these flat pack module units. And they're on the website, and they're very low cost, so I'm bringing them here to be able to get them through permitting, to be able to bring them in and lower the cost, not only for homeless that I'm hoping for, but public in general, to be able to get their hands on a tiny home or a unit that has everything that they would need.
I love the video of the flat pack house. I didn't have a chance to get that in here. Maybe we might. I might be able to throw it in during the post game at some point. But I love the video. The problem, the one where you fold out. It looks like you drop off a container and you start folding it out and folding it out and folding it out. The one thing I noticed.
That's a flip pack.
A flip pack. Oh, okay. The one thing that I did notice with the flip pack, though, is that everybody that I showed the video to, they thought that when you folded out the roofs, that it was just a patio, and a couple of them clicked away. And I went back to them. I was like, you got to watch until at least 30 seconds, because at 30 seconds it gets like, oh wait, no, this isn't a patio. This is a whole nother, like,
yes, it's a whole house.
Yeah, it's a whole house. Yeah, exactly. So that's really cool.
And it has the bathroom, kitchen, everything's in it, and it just makes so much more sense. And this is engineering from different countries in the world that I have found, and I'm trying to bring it back to us here in the United States to take advantage of it. And it's difficult, because here we have some mentality sometimes that we know everything and nobody can match us. Yeah. Which we are starting to fall behind, and there's a lot of goodies out there that we need to take advantage of and to share, like the geopolymer and the printing and everything else.
Yeah, so that's one thing that I definitely wanted to ask you about. Now, for people who are watching from outside of Vegas, Vegas is actually ranked 7th among U.S. cities with the highest homeless rates, with 272 homeless people per 100,000 people. And so when you had mentioned that part of this, part of your goal is to use this to help house the homeless, essentially, it kind of reminded me of the project that they had running for a while in Salt Lake City, right? Where they basically just gave people homes. Now, so with us, and it got the homeless rate down significantly from what I can remember. It was something like, it was down to like 0.5% of what it was, or just unbelievable numbers. each person basically got a home and they got a social worker, like, I don't think they got them to themselves, but like one social worker per, I don't know, I can't remember off the top of my head. It was like 10, 20, 50 people to kind of help get them back off their feet and back on their feet rather. So I wanted to ask, like, have you been in contact with, with Vegas having this big gigantic problem and all that? And I'm sure that once like the foreclosure protections run out here in a couple of months, or wait, I think they are starting to run out now, or this in September. I'm sure there's going to be more homeless. So
I think the next couple of days.
It is the next couple of days. That's right. Okay. So have you been in contact with like the city of Las Vegas or Nevada or?
I have had a myriad of meetings with both the social workers of the county, North Las Vegas, planning, on and on and on. California spent over $100 million for homeless and never built anything. So I'm not sure government is really the answer. I'm sticking with the people. I think that we need to come together and solve this problem in spite of those that are claiming to be the ones that are supposed to solve it.
So how would
kind of what I'm doing.
Yeah, how would that work? Do you think? So you're saying that an individual would buy a house to give to a homeless person, or I don't understand.
We have a nonprofit side that we're working with, and we're going to start small and learn to duplicate. There's a couple of things that we're looking at, because in our society we work on a monetary value, so that just because you have housing for somebody, then you have other issues that they're going to need, like food.
Yep.
So in our program with our housing, we have two main areas that we offer for work. One is for food production. In our warehouse, we do have aquaponic systems where we grow tilapia and shrimp, so that we would have places that people can go work, earn money, pay for their dwelling, and then have leftover for them to save or do whatever they wish. The other area that we're working in is building products, and we're looking to be able to start making building products out of the sustainable materials and geopolymer, so that we would be able to create more habitat to have people live, to have more jobs. So it's a cycle we're trying to create. Sure. We're trying to start small, so then we can then duplicate that.
Interesting. Okay. So it sounds like, so how do you keep it from turning into like a company store kind of situation where, like, because the coal miners, just in case, I'm sure no one gets that reference. The coal miners used to, they would work for the company and then they would receive their pay in scripts or coupons or tokens or whatever that were only good in the company store. So the company was making money off the front end from their labor and then off the back end from their labor.
We're not trying to control people's lives.
No, I didn't think so.
We're trying to create systems that people can take advantage of. And it's not just homeless. People on low income. We're looking to lower the cost of housing and integrate technologies that can help lower the cost of living. So that if we have places where we can grow food, because they're going to need to eat, and we also have places where we can make building materials so that we can build more and keep the costs down, then it's a cycle that helps perpetuate itself. But we're keeping it on a monetary system because that way it has its own balancing to it. People don't have to have the job. They can just live there, or they can work through to where they can earn enough to move out and get a bigger unit. It's a big project, but it's more grassroots. We're doing it, but we're also asking assistance of government in a common sense way.
Okay. Like when you said a common sense way, how do you mean?
Using technologies and doing as we ask, not what they want to tell us. As an example, had a meeting with some government individuals, and they didn't like the flat packs that were presented because they looked like containers. They had the holes on the outer corners that looked like a container, although that was just for putting flat packs together. And they didn't think that they would want to put an area together of what looked like a bunch of containers.
That's really weird. Go ahead.
We tried to explain to them that that is just a detail, a decorative strip. We can put a piece of wood across it, and we can make it look it's a box that we can decorate any way. However, most people of low income aren't as concerned with the aesthetics as the government planners would be of how they want their city to look like. We're trying to solve problems.
Yeah.
We're trying to lower cost. We're not trying to get elected, I guess you could say.
Sure. You know what's interesting about that? You say that they don't want it to look like container houses, but there's container houses that go for millions and millions and millions of dollars. Like, it depends on how good of a container house you build.
Yeah, it's amazing what some of those cost.
Yeah. You know, well, okay. Weird. So, let's see. How are we looking on time? Well, we got a little more time. So, how about, have you run into, and it sounds like kind of like you have you run into a lot of NIMBY issues? Like, not in my backyard. You're not putting one of those there.
Well, that's why we want to keep it in smaller groups, dispersed around areas. And we're also looking out of town to where people can have more of their own lifestyle. And then we also have to look at the demographics and understand that there are homeless that like to be homeless. There is homeless that have mental deficiency that actually need support and social work, and we need to be able to help provide on different levels. And then there's also the working lower income folks that just need the advantage of being able to get into low-cost housing instead of the cost of homes nowadays are tremendous, and they're made of cardboard, stick, and Portland stucco, and they run $200,000, $300,000, $400,000, which makes it impossible for anybody to actually get out of renting and own their own.
It is a challenge.
Yeah.
As someone that has done it twice now, it is a challenge. Because when I moved out here, in St. Louis, I owned my own house, and then when I moved out here, we had to rent for a while, so I basically did the same thing twice, going from renter to owner. But yeah, it's a heavy thing, man, because it amazed me, and this might be something we go back to in the post game. I'm not sure, but I did some work at a place. It was one Thanksgiving a long time ago. I did some. And I'll talk more about it later. But I did some social work, basically. They were like, "Hey, who knows how to search for things?" I was like, "Oh, I can search for things, yes." And so I did that, basically social work for homeless people. My shift was only like 2 hours. I ended up staying, I think, like 5 or 6, just because it's just this constant flood of people that just there's one guy, he gets in a fight with his girlfriend. She burns all of his stuff, including he moves to LA. His girlfriend still has a box of his stuff, including his birth certificate. She gets mad at him, burns his birth certificate. He can't get a job out here because he can't show a birth certificate. He also has to go to California in order to get his birth certificate, which he doesn't have money for because he doesn't have a job because he doesn't have a birth certificate. And it's just it just stunned me, like person after person, just one little stupid thing happens and you're homeless. These are people that want to work, but yeah, anyway, sorry.
The circumstances are pretty well set against them. And that's why we're looking to lower the cost of housing.
Absolutely.
If somebody can get in a lower cost housing, save their money to be able to move into a direction that works for them, is what our focus is. It's kind of crazy what we've created as far as our society norms of what's required and expected, where we really need to learn about taking care of each other and how we can support each other instead of what we can take from each other.
Absolutely.
That makes sense.
So what do you foresee as the like once you get a lot of the bugs worked out? What do you see as the like a cost of entry if someone wants to build a home, you know, that they can live in with geopolymer?
Well, geopolymer is probably a year or so out before we can really mainstream it. Icon, they advertised that they did I think it was a 500 square foot, 300 square foot house in 24 hours for $5,000.
Wow.
We definitely hope to maintain that or even beat it.
Wow.
And then the biggest house built printed was in Dubai, and it cost $100,000. The nice thing is that the technology lends itself to not a lot of people need to work on it because the printer does all the work. My key was the cost of the printer. You have a lot of companies out there wanting to charge $170,000 for pretty much the same thing that I put out. The concrete has absolutely no idea if it comes out of an expensive printer or an inexpensive printer.
Yeah.
It's going to lay and do just what it's always going to do.
Sure.
So my whole goal was to make it open source and to be able to bring it to the next generations out there.
Yeah.
That look at, I can't afford a $179,000 printer, or I could build my own in the 20s and get a group of people together and start community and working together and using some of the technologies we have for aquaponics and the solar systems that we can start integrating and bringing in low-cost housing, and then I come in and fight for the code. I'm talking to the county that this is what the code says. You can't tell us we can't do it because law states that you can. So just because you haven't seen it before or you don't feel that it's right is not the issue. It's we have a right to be able to help lower the cost of living and to live the way that we choose in this country.
Yeah, that is super, super interesting. Any final thoughts, Crux, before we shift on over to the post game?
No, I mean we can go into more details on some things in the post game. So
yeah, I absolutely did want to do that. I got all kinds of questions for you, like how you put conduits in, foundations, site prep, all that stuff, and also I want to see, and I have a feeling that this might be the Coke versus Pepsi of 3D building. Is gantry or robot arm? Answer just may surprise you, but not yet. We're going to do that when we come back. So what we're going to do, we're going to take a quick break here. And again, we've been talking with William Hoff from Out of the Box Construction. And we're going to have all kinds of links down in the it's over there. Down in the doodly-doo down there. When you're watching this on YouTube, you'll have all the links to that third dimensional printing, and you there in Twitch right now, you also have links to all that stuff in the chat. But yeah, we're gonna go ahead and take a quick break. If you're on YouTube, that's the end of the show. See you next week. But if you're here on Twitch, stay right where you are, and we will be back in 5-ish, 10-ish minutes, something like that. All right. Hi, I'm the Mighty Pong, host of the show that you just got done watching. Hey, if you'd like to see the entire show and not just the first hour, make sure that you watch on twitch.tv/Synshop every Friday night for the main show. And on Monday nights, we have our special project night. So you can join us, build something, and basically throw stuff at us while we try to concentrate on things. It's a lot of fun. Kind of. But hey, anyway, we hope to see you there. It's a lot of fun. Yeah, so join us over there, twitch.tv/Synshop. I am, of course, the Mighty Pong, and we will see you there. One take. Not one take.